Hello.
Hey, wow, your audio is different.
Who's mine?
Yeah, like all of a sudden it's
Nathan? Do we have quorum? Is it different or the same?
You sound real close to the mic.
That could
Yeah.
be why. Because it's right here.
Nice.
I move around so much. I have the worst ADD and I'm constantly moving my microphone around. So sorry.
It's all good. No big deal. I mean, it's
tend to
better
do
than
this.
not hearing you.
Right. That's a plus.
All right.
So
Wow. We have Nathan on the couch today.
Hello, how's it going?
I mean,
it's kind of a big deal.
It is. It's a big deal. Like, we don't get to see Nathan very often, so it's awesome. I'm gonna actually pop you up in the prime spot up here, so everyone can see.
I think Brent's a little possessive of the couch here because he had to move himself to the couch.
Yeah, that's not true.
You look real comfy down there now.
I just know that what happens in the future of this show, like, in a few minutes when we start screen sharing, is this will be the face that gets covered up by the commentary that pops up. So I'm just trying to, I'm thinking of you guys, people are here to see you.
Taking one for the team. That's a team player right there.
Exactly.
That's leadership.
Exactly. Nice. Oh man. So Mini Jerome is back. Welcome back, Mini Jerome. And of course, Alex Smasha. Wow, writing code. Here we go.
I already see some CDK there. I like that.
I know, that's awesome. That we need to write that high-level construct. What happens on the couch stays on the couch. Well, and on recorded video, that's pretty great.
True.
And new person joining, Faradu, maybe, I don't know how we'd say that, but welcome. Glad to have you on the show.
Welcome. So it's like you said, it's always great to have Nathan on the show. I'm personally a big fan of yours, Nathan. I love what you kind of evangelize for ECS and just for containers in general. So prior to coming to this team, I was always following you to see what Nathan was going to say next. And so today we're going to obviously talk about CDK. We tweeted about it, but maybe let's just start with tell us, for those who don't know what the CDK is, Nathan, let's talk a little bit about that. And then let's maybe talk about the service extensions for ECS. Why did we do it? And what benefits are we going to get from it? And then there's going to be a great demo, of course, right?
All right. So first of all, AWS CDK, three-letter acronym there, but let's talk about what it stands for. It stands for AWS Cloud Development Kit. And so at a high level, what it is it's a SDK that you can use in your favorite programming language. And you can use this SDK to create infrastructure on AWS to deploy your application and support your application. And it's really powerful because it enables programmers to really have full control. I remember in the past, a lot of times when I was writing code, business logic for different companies, I ended up in these awkward scenarios where there was this separate cycle for, okay, I'm writing the code for the future, and now I gotta wait on somebody to provision a database, or I have to wait on this or that, or now I have to get out of my IDE and have to go over to this web console and start clicking around some buttons. And so one of the things that I started to get excited about with at that time was infrastructure as code. This idea that I could describe the infrastructure that I wanted to create using JSON, YAML, or whatever, and then I could just say, give me this stuff, and it would give it to me. So I think Cloud Development Kit is really the next step, next evolution of this concept of giving developers the power to create things from right there inside of their IDE. I find the best way to sort of describe what CDK does for you is to actually show some sample code. So once I share a screen, I think you'll understand, like, as a developer, this is a really powerful toolkit for me to be able to create not only application, but all the supporting stuff that my application needs as well.
Go ahead, Adam.
Nope, you go first.
You mentioned, creating infrastructure as code. I mean, there are tools out there that do that already.
Mhm.
CloudFormation, Terraform. Why create yet another tool?
So to put it simply, it's because when I'm writing infrastructure as code using Terraform or CloudFormation or Kubernetes, YAML, whatever format that I'm using, a lot of times I'm looking at hundreds, even thousands of lines of configuration. And a lot of these configuration sort of descriptions of the infrastructure as code, they don't have control mechanisms in them for doing things like, I want a dry, do not repeat yourself pattern. I want to have something, some little piece that I can reuse in multiple places rather than having to create it from scratch every single time. So what ends up happening is, when I'm working with these large YAML files or large JSON dumps for infrastructure, so I see these same patterns repeat over and over again. And then when I go in there to modify it, I have to track down every single place that this particular pattern is repeated throughout the code base. So what you end up realizing really quickly is I need some higher level tooling on top of this. I can't just do this with raw format. I need some kind of templating language, some kind of way to say, like, here's a little piece of JSON that I'm going to reuse here and here and here. And then from there, as you start looking at this problem, you're like, okay, I can make this smarter. I can start adding more and more logic and generation capability to turn this from thousands of lines into just a few lines of logic that then generates the rest of this thousands of lines. So that's what I'll show you later on. I do a little screen share, like what CDK looks like in usage versus what it produces for you.
Yeah, and to speak to that point of, listen, if you're creating CloudFormation or Terraform, by the way, these are great. Like, it's not that there's anything wrong with them, but if you're creating CloudFormation templates, you have to know everything about the environment, right? You have to essentially become an expert in everything that you're building. So you have to not only know the code you're writing and for this, this logic you're writing for the business to solve the business problem, but to solve your application problem, you also need to understand the stack. So now you become a full stack 10x developer, right? And it's hard. It's hard.
Well,
So
the way I like to think about it is like with assembly language. There's people out there who know how to write the assembly language, the machine language that goes directly to the processor. And those people are very impressive. Like when I meet somebody who knows the ins and outs of like machine language and like getting in there with the debugger and looking at that hex, I'm like, okay, this person is cool and they have deep knowledge. But that's its own domain expertise there. And when it comes to somebody who really produces a lot of value in terms of like writing code for a business, I generally think of somebody who's working a little bit higher up the stack. Like you wouldn't write your business logic for your startup that you're trying to build fast to compete in the market in assembly language. You'd have to move a little further up the stack and use a higher level tool. And so I think that's what happens with infrastructure as code too. Like you could spend a lot of time writing infrastructure as code by hand. It would be a very impressive feat to be able to achieve that. But you could also do this much faster and easier with a higher level tool like AWS Cloud Development Kit.
Yeah. I mean, when you think about, like, I don't know about everyone out there in chat, but the way I learned about AWS, or learned AWS, I should say, is I just started poking around in the console. And you very quickly realize that you can't just limit your view to one service in AWS. For you to be able to use one service, you very often have to go and use a second service and maybe a third service, or you'll get a better experience if you layer in a fourth service. Like, for example, to use S3, you're probably also going to go and mess around in IAM. And then you're going to have to, if you're going to serve anything out of it for the public, you might want to start exploring CloudFront. And, it just goes on and on and on. And you discover that and sort of realize how those are singular things when you're using the console. But when you're trying to write it in CloudFormation, there's nothing that leads you down that path. You have to go and like actually know it already and sit there and just type stanza after stanza after stanza, creating that infrastructure along the way. And you have to understand how it all fits together.
Mm-hmm.
So moving, like you're saying, moving even further up the stack, its CDK is really nice because it can know that for you, and you could be back into the position of give me an S3 bucket. And, like you just get it and you can sit there and start using it. So, and it takes care of all the other stuff.
Yeah. So speaking of levels there, I want to show, maybe I can switch to the screen share now. I want to show some of the CDK documentation so we can kind of introduce the idea of levels in CDK.
You'll have to share your screen, by the way.
Oh, that's right. Yeah, let me click the right
button. To share the
here.
screen, you have to share the screen.
I'm hoping that it hasn't lost its permissions. Does that sometimes? Okay. All right, I should be sharing now.
Boom.
All right. So CDK has different levels within it as well. So if you see these right here in the documentation, there's these constructs called CFN and then a name, so like CFN cluster. So this right here is like the lowest level of what they call construct in CDK. It's a direct like one-to-one mapping between a single thing in CloudFormation, this resource right here, AWS ECS cluster, and code inside of your CDK application. But then there's also higher level, what we call level 2 constructs, and that's this one right here that does not have CFN on the front. So this one is a higher level method. If I look at it, open this up in a new tab here, I can see that there's different methods to it, like add auto-scaling group. So whereas with the level 1 construct right here, it's just a direct mapping to this CloudFormation resource. So it doesn't come with an auto-scaling group automatically. I have to create my own auto-scaling group to actually add EC2 capacity or some other type of capacity to this cluster, right? So I'm looking at creating multiple things. Versus if I go up the stack to level 2, I can just create this cluster and I can use a method like add capacity or add auto-scaling group, and it'll go ahead and create the auto-scaling group and capacity format. I can even get stuff like metrics out of this. So this is a higher level. It's a more intelligent interface for defining my cluster and creating not only the raw cluster itself, but the dependent things that it needs, like the actual capacity to run stuff. So this is what we call L2. And then on top of that, there's another level, as we call it L3. And L3 is what I really want to talk about today with the ECS service extensions. This is where it gets really interesting.
Nice.
And really quick to speak to the CFN piece. So if a feature is released with CloudFormation support, it may not necessarily have that level 2 or level 3 construct in CDK available right away. However, we should have that CFN construct available so we can at least, if we want to incorporate that in our code, it's there.
Yeah, so the CFN is actually really interesting. It's actually generated from the CloudFormation spec. So every time CloudFormation updates their spec, based on the same spec that's used here in the documentation, all of these different parameters for a particular resource, CDK actually regenerates the CFN lowest level resources automatically based off that spec. So at most, I think there's generally a release about like once a week, sometimes a little bit faster. So there'd be like maybe about a week lag between something being added to CloudFormation and being added to the CFN server.
And yeah, and so fair ducks. I'm going to say ducks. Brent says fair de. I don't see an E in there, so that's why I say ducks.
Oh, I guess I'm very French.
That's what I was going for, the French. But what they say, one amazing feature of CDK is the IAM role creation. And I meant to talk about this earlier, but this is, again, the difference of you being an expert, having to know all the assembly language, or relying on the experts to connect the pieces for you. And when you get those higher level constructs, and, like my favorite thing is, for example, DynamoDB, there's a method, add or grant read write, or grant write. I call that method, I pass in the object that I want to grant the access to, and it's done. So that's a great point. It's because IAM is hard. Yeah. I've said hard a lot today. Like, things are hard, But as you start going up the stack, it becomes easier and easier. It's eliminating the more difficult components with best practices.
Yeah, so just to elaborate a little bit on that comment for anybody who's not super familiar with CDK yet. So here's an example of creating a containerized service using CDK, and this is the L2 construct. And you can see that it implements a bunch of these different types of interfaces. And these interfaces essentially add capabilities to the service. And one of these things is the fact that it has a role. And so it creates a role automatically. Where's the property for that? I know it's somewhere here on this list. I didn't find it ahead of time before I went into this list here.
Is it under
it's on
task
the,
definition?
Yeah, you're right. You're right. It's under task definition. So if I go into the task definition and look at this type, I see on here the role, task role. And so if I go down to this, that's the interface role there. So one of the cool things that it does is it automatically creates an IAM role for the resources that you create on your AWS account. And that can be tricky a lot of times because there's a tendency if you're creating things by hand to say like, well, I'll just reuse this role everywhere because I don't want to have to create another one each time. Well, this kind of CDK kind of enforces in a very nice manner that each of your things on your account has its own unique role that has its own unique access. And so you know that you have like a security posture that's secure by default. It's locked down by default. And then you can add progressively different levels of access for each of the things on your account.
That's awesome. There is a question from 28 Mental. Is this CDK impacting Terraform? I'm guessing, do I have to know more when I use Terraform? And yeah, I'm wondering, can you remind us about exactly Terraform CDK?
Yeah, I'm already bringing it up. So is it impacting Terraform? Yes, in a good way. You see this project is actually, it's right there on the HashiCorp, what's it called? The HashiCorp organization, Terraform CDK. So the idea is this is CDK, which then generates Terraform under the covers, because CDK is an engine. CDK is like, I have the concept of higher level abstraction on top of my infrastructure as code, which then synthesize down to infrastructure as code for me. And that infrastructure as code could technically be in any infrastructure as code language. It could be CloudFormation, it could be Terraform, and we even support Kubernetes YAML as well. So the possibilities are endless. So if you're a Terraform fan, CDK for Terraform may be for you.
Not sure if we're going to know this one, but NetHole asks about a related Terraform question. Does the CDK have a mechanism to allow post-instantiation exec commands? Think of post-configuration for clusters, looking for the possibility to replace the use of Terraform with CDK instead. Mm-hmm. And I mean, at the end of the day, you're writing in a programming language, right? So could you use that to your advantage, or would you have to have some kind of exec happening like at the CloudFormation or Lambda level?
So I know how to do that in CloudFormation. Definitely will be using a custom resource. And the reason why you want a custom resource is because resources get created at different times. So you think about all the resources, there's like a tree of dependencies. This resource is created, and then once it's created, these three resources that depend upon it can be created. And then there's like another resource that depends on one of those resources. So there's like a dependency graph that goes down. And generally these type of like post-creation execution type things need to happen only after the other resources have been created. So you probably want to use what's called a custom resource, which is essentially a Lambda function that hooks in and says, once these other things I depend upon are ready and created, I want to execute and then do whatever action I wanted to do like a custom task of some sort to prepare state or prepare the resource in some way.
Yeah, so even though we're using, for CDK, we're using a language, a high-level language to write it, it gets, like Nathan said, it gets synthesized down, so it's not like you're actually running that language against your infrastructure directly. You're outputting something that's slightly lower level and then applying that to your infrastructure. So yeah, don't think. I guess it's probably worth pointing out you wouldn't combine your CDK code in with your app code like together in the same set of files or application or anything like that.
Although I have seen a really interesting framework that started to implement something along those lines.
Oh, interesting.
Yeah. The idea was you could essentially create a function in your application code that would automatically deploy as a Lambda. And you could create like a table and interact with it in your application code, and it would automatically create a table in the cloud. So it was like a multi-form app. That application was both infrastructure as code as well as the actual application logic. I think it's still very early days in that type of concept, but I think it's promising. There's a lot of interesting potential there.
That's pretty bizarre. Very meta.
Yeah, extremely.
Nice. Awesome. All right. So we have, what are we calling the level 1 stuff again? We don't call it level 1, do we? We have level 2 and 3, but
so I think we were calling it L1, level 1 as the CloudFormation.
Okay.
So I want to show this. So this CloudFormation service is level 1, and then one level above that we have the sort of level 2. Actually, I guess a base service is fine. So this is the level 2 service, and this construct still requires you to understand and create some things like a task definition. And if you do want to say like attach to a load balancer, you have to create that load balancer yourself, and then use this method attached to classic load balancer or attached to network target group or something like that. So you still have to create some extra resources if you do want to attach this service to something else. So what I want to introduce now is level 3. What does level 3 look like? Going back through CloudFormation, level 1, base service, level 2. What does level 3 look like? And so that is the developer preview that we recently launched called ECS Service Extensions for AWS Cloud Development Kit. And so this just launched. It's pretty new. I want to say a big thank you to the probably roughly 174 people or whatever who have already tried this out and experimented with it over the last couple weeks since it went live on NPM. Hopefully we'll continue to get some more experimentation and feedback before this goes into general availability. So this is still experimental for now. That means that there could be some breaking changes in the API, but we're going to try to keep that to a minimum if we possibly can. And the idea behind this is it's what we call an L3 construct. So it has even more intelligence built in terms of how you define your infrastructure. And I want to start with the example code to show how this all works together. So it starts out, I'm just importing some classes from this ECS service extensions module. And then from there, we start instantiating some of the things that we're going to need for our application to run. So the first thing is always an environment. So creating an environment, if you think about what your application needs to function, it needs a networking stack. So it needs its own little isolated chunk of the AWS cloud to have its own private networking inside of. And it needs a ECS cluster. It needs capacity to run that. Maybe it's Fargate, maybe it's EC2 capacity. So it needs a few different things baseline just to even say, okay, I'm ready to launch a service now. So that's what this is designed for. It's designed to be super simple. Everything that I need to launch an application, a containerized application, is encapsulated in this high-level environment construct. I don't have to think about VPC anymore. I don't have to think about clusters and cluster capacity, providers, or anything along those lines. I just say, give me an environment, and here's the name that I want the environment to have.
Holy cow. So you'll get a new VPC, right?
Mm-hmm. Yeah. So each environment is designed to be isolated from other environments. So that means it has its own isolated networking stack, its own isolated cluster and capacity.
Nice. Is it possible to target an existing VPC?
It is. It definitely is. So that's documented here. By default, this is the way I like to use it because I just want the construct to provide its own VPC and cluster. But you can also create these things externally. Like if you already have a VPC that you're forced to use by maybe some ops team in your organization, you can just import that and use that VPC or that cluster that's pre-created for you.
That's awesome.
And so from that point forward, it will understand, okay, this is the environment that I am actually going to be deploying into.
And with environment, could I, so if I have a microservice stack where I want to deploy maybe multiple services to the same environment, but they don't live in the same stack, is that achievable yet?
Yeah.
Or okay.
Yeah, it is. So one of the nice things I like about CDK is it handles all of that automatically. So if I do split my CDK app across multiple stacks, it'll automatically create the appropriate imports and exports in order to pass values from one stack to another stack. So I could create the environment in one top level like base stack, and then I could pass that reference just in my code the way I always do. Maybe a global, it could be anything. It could be a global variable. It could be a class property, something along those lines. I just pass it through the context in the CDK application. And then CDK understands that this is a value that's referencing something in a different stack. So I need to automatically create imports and exports to sort of pass this value through the CloudFormation stacks over to the destination stack.
Thank you for throwing that in. I was going to say, for clarity, the word stack here in this context is a CloudFormation stack.
Yeah.
And that's, I was thinking a little, beyond that though, where I already have, I may manage in multiple repos, and, I may not have that object to pass back into, my new environment object that I'm creating on my new stack. So can I just export this as like a cloud? I guess I would just export the cluster name, the VPC name, and then import those in my other stack. This is probably a little too deep.
Yeah, I think that's a perfect use case for this usage right here, where you're passing in a specific VPC and cluster. So if I did have multiple different microservices and I was finding like a micro repo strategy where each of my services had its own micro repo and its own CDK application, I would probably use this form of, I already have a VPC, I already have a cluster, I just want to pass those in and use them.
Yeah, and then you just use the from lookup object and method, and that's how you import those in. That makes sense.
Yep. So before we run out of time, I do want to kind of go through there. I still want to do a demo, so I don't want to run out of time on that.
Good point.
Let me show the rest of the top level things inside this new CDK module. So the next one is service description. So the service description is basically just describing what your service is that you're deploying. And if you're familiar with ECS, you probably know the idea of a task definition. So service description is like slightly higher level task definition that supports more things. And creating it is very simple. You just say new service description. That's the starting point. Starts out empty. There's nothing inside of it. And then it has one method called description.add. And then it allows you to add things to your service description. And those things that you can add are called extensions. And each extension essentially builds out, it's like a little building block, a little Lego brick you can snap together to add your application or different pieces of application functionality to your service description that will then be turned into a service. And we're launching initially in the developer preview with a suite of different extensions for a wide range of different functionalities that used to be a little bit complex to configure. So stuff like App Mesh, AWS App Mesh, Service Mesh, FireLens, which does log routing and allows you to tag your application logs with extra metadata, so you know like what task definition version that particular log line originated from. X-Ray, which is very cool, that allows you to automatically capture application traces of the flow of execution inside your program and send it off to AWS X-Ray. CloudWatch Agent, which captures and gathers up metrics that's emitted by your application or anything else that is part of your application. And then obviously load balancer, that's an important one. You probably want to get traffic to your application. And then a very cool one, that this one was actually recently contributed by Joshua from the community. And this one is ideal for those like small developer workloads where you have maybe a test iteration of your service, a new application version, and you want it to be really cheap. You don't want to have to pay for a load balancer or a lot of fancy networking. So this one's called Assigned Public IP Extension. And what it does is it just identifies the public IP address of any container that you're running, creates a Route 53 record, and automatically keeps that in sync as you like launch and stop different versions of your service. So it'll update this Route 53 record automatically so you can send traffic directly to your service without needing a load balancer. So
that's
that
awesome.
It's very cool contribution from the community on that one. The hopefully the first of many different extensions that people develop using this system.
Nice.
So so once you've built out your service description by adding different extensions in like this, you can launch your description as a service by just saying, okay, I want to launch a service. Here's the environment I want to launch it in. Here's the description that I want to launch. And it turns that all into a reality.
I love the way you say that. Make it so.
Like it's like this is my dream. This is my dream service right here. There's the specifications for it. Now that's my wish. Make it true now.
Yeah.
So I've got like a sample application I want to deploy here. Hopefully everything works live. It's actually 3 different services, like a little stack that I created as a sample application, which is designed to create a greeting phrase. So there's one top level service which constructs the phrase and returns it back to you. And then underneath that, there's a service that returns a random name, and then a service that returns a random greeting phrase like hello, hi, good evening, whatever. So the idea is greeter service will use these 2 services to construct a random phrase like hello, Nathan, hi, Adam, or whatever. So it'll put this all together. So it's a simple 2-tier application, load balancer. You hit the greeter service hits these other 2 services. And I want to use a service mesh. I want to really enhance this with everything I can possibly think of.
Yes.
This is going to be the most gilded example service ever.
Exactly. That's amazing.
This thing is loaded and ready for production.
Yeah, I'll show you in ECS what it looks like with all the little sidecars and stuff that we're using for this. So I'm just going to type CDK deploy app. What's it called? It's integ. What is my service name again? Oh yeah, all service add-ons.js. What did I do? Am I in the right? Oh, whoops. I forgot I need to make this 2 dashes here. Classic mistake. Okay, so first of all, just to give you an idea of how much configuration is sort of hidden away by this level 3 construct, look at all of these permissions and things that are being created. So these are just the IAM statements. So obviously, if I'm creating something with service mesh and logging and tracing and all these different bells and whistles turned on, there's a certain amount of complex permission model that's required for this service to be able to talk to all of these other AWS services. And so you can see that a list of just a little preview, an idea of like how much is being configured here before I even deploy this. Is giving me a little preview.
And I love that it's still, I mean, that's a lot, certainly, but it's still like minimum required.
Exactly.
So, that's why it's such a long list, because it's not just star,
Yeah. It's very tempting sometimes to just be like, well, I'm just going to give this thing access to everything on my AWS account. But that's obviously like a really bad idea. And so what this has done is I didn't have to go through and do a lot of rigorous thinking about it. It understood that each of the components that I enabled here in my code, like AppMesh or X-Ray, requires a certain minimal extension, minimal permission model for that particular extension. So AppMesh needs to be able to talk to AppMesh, or X-Ray needs to be able to talk to X-Ray. And so it compiled and added all of these extensions together to create the final permission model for each of these individual services.
Can you quickly just cat your code and pipe it to word count -L, and then cat the CloudFormation artifact to a word count? This is something that's it really shows the difference.
Oops, I don't want to do that. I wanted to create a new shell. Where's my plus button there? Okay, let's see. Where is my C packages? AWS CDK containers.
I really need to convert to VS Code.
Oh yeah, it's great. It's great. Unfortunately, I think I just accidentally messed up I'm using the wrong shell, so it doesn't have tab completion.
Yeah, you picked SH. So
yeah, I accidentally clicked on that. It's supposed to be bash, I think. Yeah. I knew I messed something up. Okay, what was that command again?
So cat whatever your code. Oh boy. Yeah, there's no tab completion. That's awful.
I know this is going to be bad.
Type it to WC.
It's WC, right?
Yeah, -L.
Was there any -L?
Yeah, -L.
Okay, so this will give me line count. So 92 is the line count. And then I can actually show you the JSON that it generates for the configuration for all of this stuff. Because I have it here in this as an expectation.
Clonky Donk says
name of the day.
You could type bash to get into bash real quick.
Oh, that's true. I could. Okay, so this is all the JSON that it generated.
What?
I'm kind of cheating a little bit by showing it as a JSON instead of YAML, but you get the idea. I'm still scrolling.
Yeah,
scrolling down the bottom here. It says
you're at basically 30. Well, yeah,
35, 3494. So 3,500 lines of configuration here.
And you had less than 100, so 35x the amount of lines, or 1/35.
It just shows you the amount of work the CDK is doing on your behalf. It's amazing.
Oh yeah, for sure. Yeah, it is. It amazes me every time that I see it. It feels good, and I don't really have any worries about this because I know that it's following production best practices. So I know that it has the minimal security groups. I know that it has the minimal level of access that it needs to all the resources. So let me show you what it's doing right now on my account. While it deploys that in the background, go over here to CloudFormation, and let's see. Am I in the right region? I don't think I am.
It's always the region.
I think it's deploying this in. Oh yeah, there we go. Okay, so it's creating a list of 90 different resources. So, I mean, you can kind of see how simple that TypeScript code was with less than 100 lines there, but that expanded out to 90 different resources that are required to have a fully auto scaling, service mesh enabled, traced with logs and like log routing and everything that I might need for all the bells and whistles. And you don't necessarily have to enable all of this. This is deliberately showing like the most complex thing that you can possibly put together.
This is that top of the line car, like with every feature you want.
That's right.
I don't necessarily need for this, but
you checked every option. But I mean,
I always love doing that too when I'm shopping. If I'm looking at like buying a pre-built computer or something, like turn everything up to the max and see like
$10,000. Just the biggest computer out there, the most powerful. I'm with you.
Oh yeah. So with this framework, you can actually do exactly that. You can say, let me test all these things out. And the advantage of the cloud is you're not buying all this stuff up front, right? So you can turn on all these features and play with them for 10 minutes, 30 minutes if you want to, and then turn them off. And you don't have to continue paying for this. In fact, a lot of this, like for example, app mesh, the service mesh, you're not paying for the control plane or anything like that. You can play with it as long as you want to. You're just adding a little bit of extra capacity to your particular task there. So I'll show you what it's actually creating, because this is kind of cool to see. if I go into the task definition here in ECS and look at what it has configured for me, it has my application container here, but then it also has 4 other sidecar containers that is configured. And so normally this is something that I would have had to configure all of the stuff in my own task definition by hand. And so you can kind of see what the JSON for the task definition looks like. This JSON here in the task definition is also pretty extensive. It's a lot of configuration here that I would have had to create to define this application and its entire environment of sidecar dependencies in the stack. But I didn't have to do that because it did that for me automatically. And
you have the task role assigned there, so you can see the IAM policy. I mean, I love CDK. I could just watch this all day.
Me too. So another thing I want to highlight about this, and this is something that I made a pretty deliberate choice when designing the service construct here, is you'll notice under compatibilities and requires compatibilities, it has both EC2 and Fargate. So a lot of times, and this was true of like the level 2 constructs that we had before in CDK, you had to make a decision between, am I developing this for Fargate or am I developing for this for EC2? And you actually had to use a different construct and understand that, okay, I'm creating an EC2 load balance service, or I'm creating a Fargate load balance service. And switching between the two wasn't particularly easy. Well, what this level 3 construct is designed to do is target the set of configurations that works across both platforms. And so this task definition is now actually capable of deploying on either EC2 or Fargate. And I can easily switch back and forth between the two. I could even have like mixed capacity inside my cluster. And, some EC2 maybe as like a baseline, some Fargate that I could like burst capacity onto. So this will become more and more interesting over time as well, as we add more capabilities in the capacity providers to allow you to run these like mixed class services that maybe are partly on the serverless Fargate capacity, partly on a traditional EC2 capacity that maybe you have like a compute savings plan for, or something along those lines.
Yeah, and that makes a lot of sense. This was very two-way door thinking here. I like it.
Yeah, this is my idea.
And when you're running, do I have the ability, EC2, obviously there's a little more system level functionality that I can add to my task definition. I can do that in the CDK, right? If I want to expand my service to run on EC2.
Yeah. You sure can. You can configure a lot of the stuff underneath. So one of the goals with this level 3 was to do a lot of stuff for you by default, but still allow you to override things on your own if you want to. So here, okay, my service is up and running, and this service has, like I said, it has all the bells and whistles. It doesn't look fancy on the surface, but we know underneath it's fully enabled with all these capabilities. And so basically what it does is it just has a random greeting phrase and a random name, and it constructs the phrase. And I can see based on these IP addresses that we're hitting different tasks, and these things are switching back and forth. So I'm load balancing across these different destinations. This one right here is static because my browser has a keep alive connection between my browser and a single backend. But the others you'll see go back and forth because we're load balancing it within the service mesh itself across these different tasks. And so I can dial this up as much as I want.
That's awesome. Does it auto scale?
To answer that question though about, can I modify the system level settings, I want to get back to that because that's interesting. One of the things you can do is you can create your own custom service extension. So like I said, we're shipping this in developer preview with this set of extensions that do different common AWS specific tasks there. But you can actually create your own particular extension if there's a particular piece of logic that you want to configure. Maybe you want to add like a custom sidecar to your services, or you want all of your developers to have one consistent setting as far as like auto scaling or something like that. So creating an extension is super easy. It's basically you just extend this class called service extension in your own code. And then the class has different hooks that you can implement. So for example, there's a hook for modifying the service properties. And this hook just passes in a proposed set of service properties. And you can modify those any way you want. So here I'm saying expand the existing service properties and make a modification to it, which is I want my service to initially launch 10 copies of the service rather than whatever the default is, which is 2. And then I want to return that. And so then also here in this case, this hook is for using the service. So it's saying I'm passing in a service that was created. And in this hook, I'm able to utilize the service by making some changes to it. So here I'm setting up a custom auto scaling for task count and creating a custom rule for how I want to scale. So then this entire thing right here is packaged up under the name My Custom Auto Scaling. And I can reuse this custom extension that I built and I can ship it to other developers in my organization. So imagine this could be like My Company Auto Scaling, and you can centrally manage that. Now, if you're a developer and you have, let's say, 20, 30 different services, you can have them all using your own specific extension code, change that extension code in one place, and everybody who's making use of that extension gets this update to their service.
It seems like, so this is kind of unrelated, but I bet it's useful here. You wrote a blog post recently, I'm going to paste it in chat, about speeding up ECS container deployments.
Oh, yeah.
And, you went through a lot of, if this, then that type logic. I feel like if someone were to do that in their own environment and their own like enterprise, they, maybe they're a node shop and they know that my container can be up and available in 1 second and can respond in, to a transaction in, 100 milliseconds, that kind of thing. So they know that about their application. They could then write their own custom, timing for health checks, draining, and all that stuff.
Yep.
And you could get your ECS deploy times down to, to be super, super fast just by following your blog post here, plus, incorporating in what and have that just be the default for all services that get deployed in your environment.
Totally. Yeah. So I have a couple different concepts on that. So one way that you could possibly do that is using a service extension. There's another sort of, like I said, this is developer preview. So we're considered experimental. So it's not 100% done yet. There's still more to add in the future. And one of the things that we want to add in the future is something that we're calling traits. So the idea behind traits is it's a higher level bucket for defining a configuration that will potentially change multiple other underlying configurations or how certain extensions behave. And so an example of a trait might be, I want to add the low cost trait to my service. And so what that would do is it would say, okay, I know that this is supposed to be low cost. So maybe let's go with the most minimal task size that we can. Let's try to optimize the networking and load balancer and everything else to be as low cost as possible. A potential trait would be like, I want this to be a developer environment that has the fastest deploy. And so it would go through and reconfigure all the settings for that optimizing ECS deployment speed, everything that would be needed for that. So if you're actually interested in that, you can read more about it here on my blog. The full RFC for this module is posted here, and down here toward the bottom, there's a little section that talks about some of the ideas behind service environment traits. So this isn't in here yet, but it's targeted as something that I hope that we'll be able to add in the very near future. Perhaps whether or not it comes in before we go general availability with this module, I'm not sure yet. Like I said, still developer preview, depending on how the timing works out. I think this is going to be really interesting though, because you'll be able to choose like essentially this list of adjectives. Like I want to be cost optimized, I want to be performance optimized, or I want to be high availability.
Everyone's going to pick all three, right?
Yeah. So that's where it gets really interesting, is the idea that traits will be able to preempt each other or have like a priority, where, for example, high availability could say, I know that cost optimize wants to do a single container deployment. However, high availability requires that there be at least 3 and 3 AZs. So it's going to be interesting. Right? We still need to work out the whole spec for how that is going to work. But I think the idea is to really get away from, I want to set this configuration directly, get away from that to, I have this high level intention for how I want things to work overall. And based on my intention, I would like the service, I would like the extensions to automatically configure themselves according to this high level intention.
That's awesome.
It's really good.
I've seen questions in the past around, especially when using auto scaling and some of our like automated things that change the state of your environment. What happens when, let's say you use the CDK, you generate your CloudFormation, it deploys your app, and you get 3 of them because you wanted it to be highly available, whether you're using the trait for it or not. And then auto scaling comes along and scales you up to 20 copies, because you just have that much traffic coming in. What happens on your next CDK deploy? That like, will it knock you back down to 3, or and then you have to auto scale up again? What happens in that situation?
So this is a problem that I didn't solve in this particular L3 construct yet, but I hope to add in the future with a custom resource. So unfortunately, right now with CloudFormation, every time you do a new deployment, it would roll back to whatever you define in the deployment. So if you start out as 3 and then it had scaled up to 20, there would be a brief period of time where CloudFormation would scale you back down to 3, and before auto scaling, kick back in and scale you back up to 20. So obviously that's not ideal. There's a interesting solution I saw to this recently, which uses a custom resource to essentially read the current value of what the scaling is at and ensure that exact same value is used when the CloudFormation update actually goes through, because it essentially does a read right before it does the write.
Nice.
So I haven't integrated that in here yet, but that's an example of something where that's a sort of an internal implementation detail that I, as a developer, shouldn't have to think about. Ideally, right. Like, I just want my auto scaling to work out of the box. Like, the fact that I have to think about that, it's not ideal. And so that's something where these tools can be made, because they're at that level 3 level, they can be made much smarter and able to predict what your intention of intended behavior is, rather than sort of taking the configuration at face value.
Nice. That is going to be awesome. I mean, this whole thing is awesome. But that's definitely something that, we've seen it come up time and time again. So to have such a clean solution and have it be built in, and, all of this stuff, clean, one liner and you have app mesh, and one liner and you have X-ray.
Right.
So,
Can we see some of these metrics in the console?
Let's see.
Because by the way, you deployed all of this in, how long did that take when you ran a CDK deploy? It was less than 5 minutes.
I don't think it was that long. I wasn't measuring. I'd guess maybe like 10 minutes or so, based on the fact that I've done this a few different times. I know it's 10 minutes. Let's see. I don't think I can see the metrics for this yet, because there's no traffic actually going to that.
Oh, got it.
But I do have another one that I had launched before in the past. I think it's in US East 1. Yeah. And you can see some metrics for that if I go to CloudWatch. You can kind of see what the type of thing that this enables here. So this is a cluster of several different services, and it's built a dashboard for the different metrics that have been emitted by like the service mesh and everything else. And so here you can see, for example, the number of requests per minute. You can see P95 response time with a little spike here. It's kind of interesting. Running task count, memory utilization. And then that X-ray extension, the thing that it enables is here under service lens. If I look at the service map, I can see now a map of all my different services and the requests going from one service to the other. So
That's incredible.
Yeah. So all I had to do was drop a little bit of code into my application container and then drop in that X-ray extension on my ECS service, and it automatically started capturing traces and sending them in. And so then I can see all these details about like error rates and stuff like that, and everything that's going on. Even this is cool, tracing across different services like SQS. So message service puts something into SQS, then SQS is pulled from by message distributor, and then message distributor, talks back to these other services. So
this is awesome. Alex Smasha agrees.
Yeah, this is one of this space of like observability tools is something I'm super interested in. I think we're going to see this become more and more sophisticated over the future, and even more exciting as things go. So,
not to really drill into it too much, but you said you only added some code to your application container. Mm-hmm. You didn't say that you instrumented your app. So
yeah. So let me see if I bring up the code for that particular application. I'm not sure I have. Oh, we got like 3 minutes left, I think.
We can run over if
okay. I don't think it'll take too long then. So if I go into one of my services, hopefully I remember this. Right here at the top, all I had to do was import the AWS X-Ray SDK, and then I did a little bit of configuration on the X-Ray SDK there, and that's what I added. And then X-Ray SDK automatically instruments and captures, for example, my calls to other AWS services. And I think I also did a little bit of custom code under this one. Yeah. So if you're familiar with Node.js, Super Agent is a pretty common tool for sending HTTP requests. So I added a little bit of code in there to cause X-Ray to automatically capture the HTTP and HTTPS requests that go through my Super Agent here. So now every time my application makes a request, it's being captured into detail that goes into the service map and gathers up all those aggregate metrics and individual traces and everything that I need.
Wow. That is so cool. And it sounds super easy. And then, of course, just adding in the necessary infrastructure and sidecars and all that stuff made trivially easy by that level 3 CDK construct.
Yeah, exactly. So by default, this particular X-Ray SDK in my code talks to an X-Ray sidecar. That sidecar needs to have a particular IAM role in order to talk to the X-Ray service on AWS. Well, I don't have to think about any of that anymore. All I have to do is add this line of code to my application to instrument inside my application code. And then the extension actually takes care of the rest. It takes care of the sidecar daemon. It takes care of the configuration for that and the IAM role and everything that I need.
Nice.
That's amazing.
Yeah, that's pretty awesome. So this is developer preview.
Yeah. So just as like a call to action here, like if you're looking at this and you think this sounds pretty cool, please do give it a try and let me know what you think, or open an issue on the GitHub. Like I said, we've already had a few people who have tried it out over the last couple of weeks, and super appreciate the feedback and a first contribution of a new extension. So if you try it out and you run into an issue, or you have an idea for an extension that you'd like to see, let me know. We're going to make this more and more full featured over time, and hopefully make it the best way to deploy a ECS service if you like to use infrastructure as code.
Nice.
One last question from me is, how does this compare to the AWS ECS patterns module? And will AWS ECS patterns still continue to grow, and this in parallel, or do we see this kind of being the next level of using CDK with ECS?
So I think the goal is that this ECS service extensions will be able to do everything that the existing ECS patterns does, and more. So, for
Nice.
example, there is no ECS pattern for app mesh. There's no one for application load balancer. And one of the bigger problems is ECS patterns is like a specific pattern that's sort of hard coded. It comes with this thing and that thing. You can't compose it programmatically. So with this, I can add any combination of different extensions in different combinations. Or I could say, I don't want FireLens extension, remove that. But I do want app mesh and HTTP load balancer extension. So this puts more control into your hands to try out different configurations and different combinations of AWS features according to what you want. Versus ECS patterns is like when you're first starting out and you don't really know what you want, it'll give you a high level pattern like here's a load balanced application. This is for the midpoint where you kind of know what you want. You want to try out these different things though, and you're having some trouble configuring it. This can help you configure any possible combination of these different extensions that you want.
It makes sense. And this is very well done. The layout, I mean, it's really easy to understand from environment to just simple plug and play what you want to your service, to your environment. This is
All credit for that, I have to say, goes to the AWS Copilot team. They're the ones who came up with like the nomenclature for saying like environment and so I tried to follow a lot of the same naming scheme that they have. So environment, service, container, stuff like that. So we'll see how it turns out. But the goal is that this will feel familiar if you're using Copilot. And so later at some point, if you say, okay, I've been using Copilot as my abstraction tool for deploying from the command line, now I kind of want to have more programmatic control and I want to enable some more of these more advanced features. It should be easy to transfer into a infrastructure as code SDK like this ECS service extensions, and everything feels familiar. And you kind of have this path toward more complexity as you become more sophisticated in your usage.
makes sense. And that Copilot team is amazing. So I'm not surprised to hear that.
Yeah.
So speaking of that, Brent, I think you're going to announce some things, but I just want to say, so next week we are actually going to talk Copilot next week. And
That's
is that
right.
next week? I'm not crazy, right?
It's next week. And
yes.
By the way, Nathan,
yes.
you around next week? feel like joining and talking Copilot?
Sounds exciting. I'll have to get back to you on that one. I am going to be probably in the process of moving at some point in the near future. So but I will have to make time for that.
That's awesome. So next week we're going to have a Halloween themed week where we talk 3 days of Copilot, and yeah, it's going to be very spooky indeed. The Copilot team is gonna write a demonstration app that is going to show off all the latest features that they have rolled out in their latest release. So it's kind of a launch, feature release type thing, and then a really deep dive into using Copilot and taking the most or making the most of it. And then second announcement, we have opened the doors for signing up for Container Day. So we're going to have a Kubernetes-oriented Container Day, Kubernetes edition, I should say, on November 17th. And it's going to be an all-day event where it's the day zero for KubeCon. So KubeCon this year was to be held in Boston, and now it's virtual. So we're going to do our day zero event virtually as well, right here on Twitch. And you'll be able to sign up, attend for free, and definitely join in there. And as a bit of a change, it's going to be all of us live. So we're going to be like scrambling and trying to run around behind the scenes to make all this work. But yeah, we're going to do the whole thing live, and there you go, doing it live. So definitely sign up. We're hoping to get registrations in early so that we know what to expect and that we can be ready to go. Speaking of going, I think it's probably time. But as you know, we won't be here tomorrow, but we'll be back on Monday. So definitely join in for next week while we talk about Copilot. And until then, see ya.
Thanks a lot.
Thanks, Nathan. Thanks, everyone.